Good evening, good afternoon, good morning. Definitely appreciate you tuning in to Driving Math with Mr. Glenn. And today we're going to be talking about how can we factor by grouping, factoring polynomials. Okay, this one is just a binomial, and so this is how it goes. All right. So let's say that it's x to the third. So you have x to the third. That means that there are three x's, right? And then you have 5 x's. Now the question is, what's the greatest common factor? And the greatest common factor simply means what's the most amount of the same can we pull out, okay? Or in this case, or divide by, or factor by. So as you can see, the most that we can take out from both is 3. So the greatest common factor here is x to the third. Okay. Let's try something a little more, not complicated, but just add a coefficient. Okay, so we're looking at the greatest common factor between these two terms. The greatest common factor between 24 and 14 would be 2. The greatest common factor between x to the second and x to the third would be x squared. So this would be your greatest common factor, 2x to the second. Now this is going to be vitally important when we begin to factor polynomials. Okay. Let's say that there were 3 terms. All right, so we have to look and see what's the greatest common factor of the coefficients, which would be 2. And then the greatest common factors of the variables, which would be also 2. So this would be your greatest common factor, 2a to the second power. All right. Let's say that there were more than one variable, one letter. The question is, what's the greatest common factor between all these terms? Well, you look at the coefficient, the greatest common factor would be 7. Look at a, the base of a. The greatest common factor is the smallest exponent. And this would be a b, not a 6. Sorry for my handwriting. That made it probably even worse. So b to the third. So 7a to the second, b to the third is the greatest common factor. Okay, of those 3 terms, all right? So now we're going to move a little further along in the lesson. And we're going to have a binomial that we're going to factor out. All right? So we're going to find out what are the factors of 6y and 18. Well, the greatest common factor between 6 and 18 is 6. Okay? So because of it being 6, we're going to reduce both terms by 6. So my greatest common factor is 6. 6 divided by 6 is 1. Then y, if I need to put that y right there, that's fine. Plus 18 divided by 6, which is 3. And so this is being factored. So this is a factor of this binomial. How do I know that? Because if I factor back, if I multiply back in, if I distribute, it'd be 6y plus 18. So there you have your answer. Okay. How about this? Okay, so we're going to break this down. So we're going to, and I did the line just because I know that I'm going to be dividing out. So I use the line to start my division process anyway. So 28, 16, and 8, the greatest common factor between those three is 4. Okay, the greatest common factor is 4. P to the 4th, P to the 3rd, P to the 2nd. The smallest exponent is P to the 2nd. So I am going to factor 4p to the 2nd out. And so what I'm left with is 24 divided by 4 is 7. P to the 4th divided by p to the 2nd. Remember, I'm same base, so I subtract since I'm dividing. And then plus, depending on what's here, 16 divided by 4, which is 4. And then p to the 3rd divided by the letter p is just the letter p. Okay? And then 8 divided by 4 is 2, and p divided by p to the p to the 2nd divided by p to the 2nd is 1. So you can also see that there are no more common factors to take out. So here's my answer. And you can always distribute the information back in if it's incorrect. Not if it's incorrect, if you need to check your work, which you should always check your work. Okay? Give me my lighting. If I distribute out, my greatest common factor is going to be w to the 5th, left with 1 minus 9w. This is my answer. Okay. All right. So that's the process of factoring out the greatest common factor. Now, if they give you where the first term is negative, then you can't have your first term be negative. So we're going to have to factor out that negative term. And we're going to factor out the greatest common factor, which is going to be -6, right? -6. And then smallest coefficient is to the 2nd power. So we have 1, that's divided by, so that's k to the 2nd, because 4 minus 2 is 2. 18 divided by 6, -6 is -3. Okay, and then negative divided by negative is a positive, so it's going to be a +2. And then 2 minus 2 is 1. And there you have your answer. All right? So if you have questions, make sure that you put them in the comment section or just rewatch the video. Okay, we're moving on to a little bit more complicated process because when I saw it, I had never seen it before. As far as factoring and trying to make sense of it was a challenge to me. Okay, so I'm going to show you what you can do. Right, we're going to find the greatest common factor between binomial factors. So let's say that we have a times b plus 4 plus b, plus 3b plus 4. Okay, now what you'll see is that this here is a binomial. This is a binomial times a number. This is a binomial times a number. All right, so what you're seeing is, you can look at it like this: ax plus 3x. What would you factor out? You would factor out the x. So this can be represented as an x. Okay, and you would factor out the x. So what we're going to do here is factor out the b plus 4. That's our greatest common factor because that's what they share. That's what they have in common. Okay, so b plus 4 is our greatest common factor. That reduces out, and what are we left with? A plus 3. This is going to be pretty significant, okay, once we move on to the next part of our lesson. All right, so if I had, let's say that I had a minus, okay. All right, so what you have is a times y plus 3 minus y plus 3. But we can't forget that this is a negative 1. The greatest common factor between the two, okay, is y plus 3, right? That's going to reduce out, and we're left with a minus 1. Okay. Don't forget to subscribe to the channel, right? Don't forget to hit the notification button. Like the video if you like. Now we have something called factor by grouping. Factor by grouping. Okay. And factor by grouping is when you have 4 terms that make a polynomial. I'll show you what I mean. Okay, so they want you to factor this. Now, groups, well, we got to put them into groups where there are 4 terms. How many groups? 2 groups. So we're going to have 2 groups. 2 groups. We're going to then factor each binomial, right, by the greatest common factor. What do they share? They share the letter A. Okay, so we're going to factor out the letter A. What we're left with? You can see it, right? B plus 7. Then we're going to factor here what they have in common. Greatest common factor is 2. That's a positive 2, right? Because I'm taking out a positive 2. Left with B plus 7. Now, just like we did over here, we're going to do here. The greatest common factor is B plus 7. So, B plus 7 is the greatest common factor. What am I left with? A plus 2. Okay, and this is my answer. Okay, and if I did order of operations, not order of operations, but if I did the area model, if I did the FOIL method, then it should add up to be this number here, right? So BA, that's AB, right? And then B plus 2, is 2B, and then 7A, and then 14. See, now it's not necessarily in order like that, but it's still the same because they have they both have terms of 1, right, or degree of 1, right? So it's okay to write it in that order. All right. All right. Now, if it were z to the third plus 8 rz to the second minus 5 rz minus 40. Okay, 4 terms, and we're going to break them into groups. It comes so natural to me now that I know what I'm looking for, what I'm doing, and that just came with a lot of practice. All right, so the greatest common factor between these, look at the r, so yeah, r, and then z to the second. So we factor that out, that's 1, and then that's going to be, so it's r, z to the second. What's left is z, and then these reduce out or cancel out, so that's z plus 8. Okay. Okay. Right, trying to make sure that the information is correct, because what I see is that if I factor out this -5, right, then something's not right here. So if I factor that out, what I'm left with is -5, and then it'll be rz plus 8. Okay, so that can't be right. So that means that I have to go back and look at my problem. Okay, and so in my problem, I see that it needs to be, well, I wrote the problem wrong, so I'm going to correct correct the problem that I wrote. Okay. All right, so that's -5. What I'm left with is z plus 8. And then I factor out z plus 8, and what's left is rz squared minus 5. Okay. All right, and there you have it. Okay. Now there may be, and this video is kind of long, just because of the different factoring examples that you have. Okay. But we're almost finished with the factoring here. All right. So let's say that we have all right, so first thing you want to do is factor out. First of all, you see that it's 4 terms, and you want to group automatically. But the one thing you want to do is factor out the greatest common factor. Sorry about the lighting down here. We're having, the sun changes every now and then, or shifts or clouds come in. All right. So we're going to factor out 6K. 6K. So that leaves us with greatest common factor is 6K. Leaves us with 6 to the third minus K to the second plus 2K plus 2. All right. So from there, now we have to break it down into we have to factor by grouping. And we can't forget about the 6K. So, however, we're going to start here by reducing by the greatest common factor of K squared. So I have K squared. Can't forget about the 6K. All right, so K, and then minus 1, factor out 2. Oh, that's what I probably wrote down wrong. Sorry. Okay, and so then that's plus 2, K plus 1, all right? And then we factor out again, K plus 1, all right? What we're left with is K squared plus 2, and here's our answer. And that, ladies and gentlemen, is a lot to know and a lot to understand and grasp and put together. But I'm sure you can do it. All right. Just practice, practice, practice. If you have questions, put them in the comment section. If you need tutoring at any moment of your math journey, just let me know. Put that in the comments. You can also email me at glenspages1@gmail.com. All right, so thanks for driving, or allowing me to drive math for you or with you. This is Mr. Glenn signing off. Have a great day. Bye.